In this tutorial, I'll show you how to analyze dependent designs. Dependent designs include matched groups and repeated measures. I recommend you follow along in the Student Study Guide with IBM SPSS Workbook. Data entry for dependent designs is very different than for independent designs. For an independent groups design study, you need two variables. One represents the IV, or the grouping variable, and the second represents the DV, or the outcome. And then the IV, or grouping variable, would be coded as 1, for example, equals one condition, 2 equals the second condition, etc. With dependent groups designs, the columns represent each level of the group or IV, and then the outcome, or DV, is entered into the rows. Let's take a specific example. This is the example from pages 214 to 215 of the workbook. This is a repeated measures experiment in which participants completed a problem-solving task in a peaceful environment, and then they also completed the same problem-solving task in a stressful environment. So our IV in this example is a type of environment, and the levels of the IV are peaceful versus stressful. The problem-solving scores are shown here. With a repeated measures design, just like with an independent groups design, each row represents one participant. So for this participant, this is the person's problem-solving scores when they were in a peaceful environment, and this is a person's problem-solving scores in a stressful environment. Now let's take a look at a matched group example. Here we have matched groups in which participants were first matched, and then participants were randomly assigned to one of 3 different conditions: unlimited use of the internet, 3 hours, or no internet. And so in this example, with a matched group design, each row represents one matched group. So all of these participants are matched, but these are 3 different participants' scores. Let's return to our 2-group example. Here we've got an IV with 2 conditions. Now when we have 2 conditions such as this, what type of dependent analysis do you think we would conduct? Here's a hint.
With T for 2, 2 for T, just me for you, and you for me.
If you said a t-test, you are correct. A t-test is used to compare 2 groups. When you have a dependent design, you would conduct a dependent samples t-test. To do that, go to Analyze, Compare Means, and then Paired Samples t-test. This is what SPSS calls the dependent samples t-test. So in this case, even though we have a repeated measures design, we're going to select Paired Samples t-test for SPSS. It's the exact same analysis as a repeated measures t-test. And then we would send over the 2 conditions we'd like to compare. I'm going to right-click on this and change it to variable name so you can see we're going to compare the peaceful environment to the stressful environment. And then simply click OK. In the output, you'll first see the means and standard deviations for each condition, and then jump down to the paired samples test table to determine whether or not the difference was statistically significant. Here we see that the difference was statistically significant at p equals 0.026, or p equals 0.03. If you have a dependent design with more than 2 conditions or 2 levels, you would need to run a one-way within subjects ANOVA. Here we have a matched group example. If you're following along in the workbook, I'm on the bottom of page 218. To calculate a one-way within subjects ANOVA, go to Analyze, General Linear Model, and then Repeated Measures. This is the analysis that we would use if we had repeated measures or a matched group. And then we can change the name of our within subjects factor. This would be your IV in an experiment or your grouping variable in a correlational study. I didn't change it in the workbook, but let's call it the name of our IV here, which is Internet Time, just to help keep things straight. And then we've got 3 levels of Internet time: unlimited, 3 hours, and no Internet. So I'm going to tell SPSS I'm looking at 3 levels, click Add. Oops, and I forgot that I can't include a space, so I need to get rid of that. And then click Add. Then I'm going to click Define. And here I'm going to just send over the names of all of my IV levels, which are the unlimited, 3 hours, and no internet. And then I'm going to click on Options. Now I'm going to send internet time over to display means for. What I'm doing here will provide the post hoc analyses that will interpret if our one-way ANOVA F is statistically significant. And then click Compare Main Effects, and I'm going to do Bonferroni in this case. And then I'm going to ask for descriptive statistics and estimates of effect size. Then I'm done with that, so I click Continue, and then OK. And then you get a whole lot of output. Yikes. Let's go through and I'll show you what we're going to focus on and what you can ignore. First, we have a reminder of how we defined our different levels. This may be important later. Descriptive statistics is very important. We're going to cover that in more detail. I'm going to skip over multivariate tests. Obviously, some people find this important. That's why SPSS provides it, but we're not going to cover multivariate tests here. We will talk about Mauchly's test of sphericity. It's just a test of an assumption. Test of within subjects effects is very important. This is where we're going to determine whether or not our F value for a one-way within subjects ANOVA is statistically significant. Test of within subjects contrast we're going to skip. Test of between subjects contrast we're going to skip. And then estimated marginal means. We're going to skip this first box, but we will look at pairwise comparisons if we have a statistically significant F. We would ignore this if our F value was not statistically significant. And then we're going to skip the multivariate tests. Let's take a closer look at those descriptive statistics. Here we have the means, standard deviations, and sample sizes for our 3 groups. Notice that the unlimited group has the highest mean, followed by 3 hours, and then the no internet group. At this point, however, we have yet to determine if the differences found here are statistically significant. Next, we look at Mauchly's test of sphericity. That is a very difficult word to say. This test basically tells us whether or not we've met our assumption. And if we had, that means that we would look at specific output in the following table. And if we haven't met that assumption, we would have to use alternative tests. In this example, we can see that P is greater than 0.05, which means that we've met our assumption of sphericity. We use that information and look at the sphericity assumed rows in the tests of within subjects effects table. These are our ANOVA results. Here we see that our F is 5.38 and our p-value is 0.011. That is under 0.05, so our F is statistically significant. We would also report the degrees of freedom, 2 and 28, as well as the eta squared as a measure of effect size. When you have a statistically significant F, you should look at your pairwise comparisons, but we only do this when our ANOVA results are statistically significant. Our results were statistically significant, so we'll look at these pairwise comparisons. These are post hoc tests with the Bonferroni correction. Notice that there are numbers 1, 2, and 3, and then repeated. Earlier, when we conducted our analysis, we defined the variables as such. 1 equals unlimited, 2 equals 3 hours, and 3 equals no internet. Therefore, here we can see that 1 versus 2 is unlimited versus 3 hours, and that difference is not statistically significant at p equals 0.29, rounded. 1 versus 3 is unlimited versus no internet, and we do have a statistically significant difference here at p equals 0.03. Finally, when we look at 2 versus 3, that's 3 hours versus no internet, we do not find a statistically significant p-value. Our p here is 0.31. And that is the end of this tutorial.